This lecture is covered the non-parametric tests, and we are going to introduce the Kruskal-Wallis test to determine whether 3 or more samples were selected from populations having the same distribution. So a Kruskal-Wallis test is almost equivalent to ANOVA test for parametric. So again, Kruskal-Wallis test is non-parametric, whereas ANOVA test is parametric test. So a Kruskal-Wallis test is a non-parametric test that can be used to determine whether 3 or more independent samples were selected from populations having the same distribution. So the null and also the alternative hypothesis for the Kruskal-Wallis test are as following. HO, the null hypothesis, is there's no difference in the distribution of the population. And HA, there is a difference in the distribution of the population. Now, 2 conditions for using the Kruskal-Wallis test are each sample must be randomly selected. And also the size of each sample must be at least 5. Also, if these conditions are met, the test is approximated by using the chi-square distribution, and the degree of formula will be k minus 1. Again, k will be the number of samples that we have. And also we can find the test statistics for the Kruskal-Wallis test. So the first we need to find the critical value, and actually to find the critical value using the Kruskal-Wallis test, we use the same table for the chi-square this also. So we know the degree of freedom, we know the level of significance, that's the alpha, then we can find the critical value. Then there we find the test statistics. Now when we get the test statistics, if the test statistics value is greater than the critical value, then we are going to reject HO. If it's less than the critical value, then we are going to accept HO. So to find the test statistics for the Kruskal-Wallis, the formula is given as H equal to 12 over N. The uppercase N will be the total values we have for all the samples. So let's say, for example, if you have 3 samples, then we had all the values, the size of the 3 samples. Then N, uppercase N1, N2 will be the size for each sample. So N1 will be the size for sample 1, N2 is size for sample 2, etc. Then uppercase N will be the size of all the samples. So when we know that, we can also find the R. So the R is the sum of the ranks of the samples. So sample 1, 2, 3. So R1 is for the rank for sample 1. R2 will be the sum for the sample 2 rank, the sum of the rank for sample 2, etc. Again, we're going to see an example soon. So let's go through the steps here. Then from there, we will look at one example before we end the lectures. So the first step, this is hypothesis testing. So we need to state our HO and HA. We also have to identify our level of significance, the alpha value. Then we can find the degree of freedom. Now, if we have the alpha value and degree of freedom, then we can find the critical value using table 6 again. This will be the chi-square table in Appendix B. Then after that, we find the sum of the ranks for each sample. So which means we have to find the ranks for all the, if the sample is 3, for all the 3 samples, then each individual sum of it. And we will see an example soon. Then we're going to list the combined data in ascending. Now, to find the sum of the ranks for each sample, we list the combined data in ascending order. That's the value from the lowest to the highest from 3 different samples. Then we sum all together. Then we rank the combined data. Then we calculate the test statistics. So the ranking is the value of R, R1, R2 for all the 3 samples. So it can be any amount of samples. Then we already know lowercase n1 to the size for individual sample. We can know the uppercase n because we had all the sample sizes and give us. So after that, we can find the H now. Now, when we find the H, as we said earlier, if H is greater than the critical value, then we are going to reject HO. Otherwise, we are going to accept HO. So we do our interpretation, the decision in the context of the original claim. So let's see example now. So this example said we want to compare hourly pay rate of actuaries who work in California, Indiana, and Maryland. So these are 3 samples. So we can say N1, N2, N3, 3 different states. Now, to do so, you randomly select several actuaries in each state and record their hourly pay rate. Okay, so that meets our condition. The sample was collected randomly. Now, the hourly pay rate are shown on the next slide. At alpha is 0.01 or 1%. Can we conclude that the distribution of actuaries' hourly pay rates in these 3 states are different? Let's look at the data. Okay, so based on the data here also, we get the second condition. The sample size are greater than 5, each sample. So California will be sample 1, Indiana sample 2, Maryland sample 3. And these are their hourly rates. So the first thing we're going to do, hypothesis testing, let's state our HO and HA. HO means there's no difference in hourly pay rate in the 3 states. HA means there's a difference. So always HO will go against HA, or HA will go against HO. Alpha is given to a 0.01. Degree of freedom, okay, the sample size, the 3 states. So K is 3 minus 1, so that gives us 2. So if I know the alpha value, and also I know degree of freedom, then I can find the critical value, which here to be 9.210 from the table. Chi-square, again, we use the chi-square table for Kruskal-Wallis test. Okay, so after that, we need to find the test statistics, the H. Remember, in order to find that, we need the R, the sum of R for all the 3 states. So we put our data in order, ranking, from the lowest hourly rate to the highest hourly rate for all the 3 states. So you can see sample Indiana, California, etc. Now, how do we find this? Let's say if Indiana is R1, then we are going to add all the Indiana, the ranking, 1 plus 2.5 plus 2.5, etc. So that's what we have in the next. So R1 is California. So we had all the CA values. Then we have R2 is Indiana. We had all Maryland. We had all. So this means we have R1, we have R2, we have R3, we have N, uppercase N. We had all the, to be 29 because the sample is 10, 9, and 10. So 29 uppercase N. N1 can be 10, N2 is 9, and 3 is 10. So we can find the H there. So we plug in the value for uppercase N, 29. The ranking, we have their sum. So that roughly gives us 13.12. So let's go back again. We know the critical value is critical value is 9.210 from the chi-square table distribution. So this means the test statistics, or the H, is greater than what? The critical value, which means we are going to reject HO. So HO is rejected. So in this case, if we reject HO, it means there is a difference. We say difference in hourly pay rates. So at 1% level of significance, you can conclude that there is a difference in actually hourly rate pay rate in California, Indiana, and Maryland, which means maybe California pay higher than Indiana, or Indiana pay higher than Maryland, etc. Now, if there's no difference, it means the hourly rate for the 3 states are almost the same. So that will be the conclusion for Kruskal-Wallis test. We use it to determine whether 3 or more, again, the keyword is 3. So we can see the example we have is 3 states. So we must have 3 or more samples were selected from population having the same distribution. So again, wish everybody the best and see you in the next lectures.